Bergson and the Holographic Theory of Mind. We'll be looking at zero time in this, the unreality of physical, which is to say mathematical law, the two are married. In this deeper into the core of Schrodinger, and at this core a repressed Zeno complex, all then lying beneath a massive structure of physical explanation. As a basis for consciousness, not even. In number 60, Quantum Jumps, not looking at Schrödinger's 1952 paper, we saw Schrödinger himself destroy the idea that his wave equation was an adequate description of physical reality. We hit the fact that within the wave equation there lies something Feynman called our jewel, Eulers Identity. Again, Euler's formula, e to the ix is equal cosine x time plus I sine x. And when x is pi, it becomes e to the pi I equal minus 1, our jewel. And we looked at this. We said, how do you evaluate such an expression? We have e is this infinite number, pi this infinite number, I is the minus imaginary plane. How would one evaluate that? Because when you take e to the I pi, you've got these infinite numbers. Well, we take an expression like this. So this is the way you evaluate one of these expressions, sort of like interest growth. And put it in the complex number plane. We have our number in the number plane there, and we multiply those two numbers. We're going to get something like that, where we begin to get a series of, or a set of triangles. Then squaring those numbers, we get something that looks like this. And we put this on the unit circle, and we begin exponentiating, increasing the exponent to the third, to the fifth, to the 12th, to the 54th, to the 100th, and we notice we're approaching ever closer minus 1. Bringing that circle, bringing those little triangles in closer and closer. But we only hit minus 1 at infinity. That is, minus 1 is always and only an approximation. Even if the exponent is 1,000,000, we're still not at minus 1. So it's only an approximation, never reached. Physics, I noted, prefers this form, e to the pi I plus 1 equals 0. Simple mathematical rearrangement. But this even more obscures e to the pi I equal minus 1. That is, e to the pi I approaches minus 1. But this is intrinsic. For physics, this wave cycles. It always returns, always returning from 0 to minus 1 to precisely 0. That is, it's unchanged. So now we look into this a bit further. We start with a fairly recent conversation between Lex and Grant Sanderson, or also known as 3 Blue 1 Brown, and all those wonderful mathematics videos he does. Lex begins, if there is intelligent life, out there in the universe, do you think their mathematics is different from ours? Grant, I think it's probably very different. There's an obvious sense the notation is different. I think notation can guide what the math is. Grant speaks of counting, increasing by 2s. Then there's this funny number system called the surreal numbers. It captures the idea of continuity. It's a distinct mathematical object. You could very well model the universe and the motion of the planets as the back end of your math and still have kind of the same interface with the front end of what physical phenomena you're trying to describe with math. Continuing, and I wonder if what little glimpses we've had of what different choices we make along the way, based on what different mathematicians have brought to the table, is just scratching the surface of what the possibilities are. Lex, do you have a least favorite piece of notation? Grant. The number e. You write the function e to the x. It implies you should think about a particular number and you repeatedly multiply it by itself. When you say, what is e to the, then you say, what is e to the square root of 2? Well, we've extended the idea of repeated multiplication, and that's all nice and well. More famously, we have e to the pi I. So we're extending the notion to the complex numbers. Yeah, you can think about it that way. In reality, I think it's the wrong way of representing this function. You could think about the problem it solves, a certain differential equation, rather than try to twist the idea of repeated multiplication, twist its arm, you will apply to complex numbers. So he continues, what if the repeated multiplication addresses is the rate at which something changes its own value? More specifically, it depends on it linearly. And he uses a population example. We've got a population up there growing with time units. And we'll say the population grows at 2 times its starting number. So our rate, our multiplier is 2. And we'll find the rate of change is proportional to the value x itself. So let's x equal 5. We start with a population of 5, right about there, and we see that it grows. 5 times 5, then 10. 10 times 2 is 20. 20 times 2 is 40. Let's go to 10. X is 10. That color. Let it grow. Now it grows much faster because the number is starting at 10. 10 times 2, 20 times 2, 40, 40 times 2, 80. So we've got a much more accelerated curve. And the little equation there would be the derivative of x with respect to time over time is the rate, or r, in this case 2, times x, which is either x 5 or 10 in our example. But he says, but this can be a different relationship. You have a ball on a string, like a game of tetherball, going around a rope, and its velocity is always perpendicular to its position. So you've got the position vector in blue, the velocity vector in red there. It's always been perpendicular to the position vector. That's another way of describing its rate of change as being related to where it is, but it's a different operation. You're not scaling it. It's a rotation, a 90-degree rotation. Grant, continuing, that's what the whole idea of complex exponentiation is trying to capture. But it's obfuscated in the notation, when what it's actually saying, if you really parse something like e to the pi I, is choose an origin. Always move perpendicular to the vector from that origin to you. Then when you walk pi times that radius, pi r, you'll be halfway around. That's what it's saying. It's kind of you turn 90 degrees and you walk. You'll be going in a circle. And you'll finish the circle off at 2 pi r. That's what the phenomenon is describing. They're trying to twist the idea of repeatedly multiplying a constant into that. I can't even think of the number of intelligent human hours that have been wasted trying to parse that to their own liking and desire, like among scientists or engineers or students. If the notation were different, or the way this whole function was introduced, I think this could have been avoided. Lex, you're talking about the most beautiful equation in mathematics. It's still pretty mysterious, isn't it? Grant, it's not mysterious. I think the notation makes it mysterious. I think that the fact that it represents is pretty. The idea that if you take the linear operation of a 90-degree rotation and you do this general exponentiation thing to it, that what you get is all the other kinds of rotations, which is basically to say, if your velocity vector is perpendicular to your position vector, you walk in a circle. That's pretty. It's not the most beautiful thing in the world, but it's quite pretty. Implicit in the discussion, Grant was always drawing on the concepts he explored in this video. How and why to raise e to the power of a matrix. In it, we again come to the core aspects of the wave function, but from a different direction. To quote Grant, if we take some operation that rotates 90 degrees in some plane, often a plane in some high dimensional space we cannot visualize, then what we get by exponentiating that operation by time is something that generates all other rotations in that same plane. And we see the picture there, all of the, well, not all, but some various implementations of this, like Pauli matrices, or I add to Grant's picture, Schrodinger, as we'll soon see. But at the core of this is an infinite operation, and a value never actually reached. In other words, at the base of physics is a sleight of hand, a feat of magic. E to the m. That is, what does it mean to multiply e to the power of a matrix, or matrix m? Well, not this, e times e times e. The actual definition is related to an infinite polynomial, describing real number powers of e. It's called the Taylor series. Here we're taking x as 2, and we're raising it by successive powers, raising 2 by successive powers, dividing it each time by n factorial. 2, then 2 times 3 is 6, and then 2 times 3 times 2 times 3 is 6 times 4 is 24, etc. along the bottom there. And rather miraculously, this number approaches 7.389, which is precisely e 2.71 etc. times e 2.71. Let's take x as 3. Again, the effect is e times e times e, 20.85, and so on. Rather cool. So mathematics guys became interested in plugging all kinds of things into this series as exponents. Note, here we're putting in pi times I, or ultimately matrices. In the bottom, now Grant notes the term exp was used as a nod to the connection these have to exponentiation, even though these things don't make sense as exponents. So back to the matrix, squaring the matrix, multiplying the matrix by itself. Here we have a matrix that we're squaring using the row by column matrix multiplication rule, and we get that result. Now we can cube it. That's what that squared matrix. Now cube it, multiply it again, we get cubed. Here to the 6th power. We're just doing this over and over, matrix multiplication. So what does it mean to take this out to infinity? Well, suppose our matrix looked like this, with pi and minus pi in the diagonal there. And now as we put that in the Taylor series, taking it out to the powers of infinity, multiplying each time the matrix, which is multiply each element in the matrix by that fraction in front of it, 1/2 or 1/6, etc. factorial. At n equal 8, we give a matrix a result that looks like the above. And at n equal 10, we get a matrix that looks pretty much like 1s and 0s. 1s in the diagonal, 0s the other diagonal. And at n equals 16, the matrix seems to converge to -1, -1, 0, 0. Now, Grant shows 1.00 here. This is rounding. It would never be this exact. We're dealing with pi, an infinite number. So we simply lop things off. We'll never get this precise 1.000. This, however, is the matrix version of e to the I pi equal -1. This matrix exponentiation, e to the m, is the heart of psi, the wave equation. What Grant shows, psi is a complex version of this general form of a differential equation. Change that vector v with respect to time is equal to some matrix times the vector, or the rate of change of some vector v is equal to the sum matrix m times itself, that is, times the vector v, m times v. M will become a rotation matrix, with little sines and cosines like this, where the rotation matrix drives the vector around in that space. Here we have where t is at 5.82, that is, we've rotated pretty much around the circle. When it's when t is equal to 2 pi, 2 times 2.14 or 6.28, we've gone completely around, done a complete or a full rotation. We're back to the start, and we'll start again. Now, differential equations, Grant noted. He gives us a very simple set of differential equations involving the love of Romeo and Juliet, where Romeo is the x-axis, Juliet is the y-axis, the x-axis the vertical axis, and Romeo's love grows up the x-axis. It's equal to Juliet's. As hers grows, his grows. And so we get this nice little set of differential equations, where this part of the differential set is saying that Romeo's grows with Juliet's. As hers grows in time, x grows. And this, notice the minus y, as his grows over time, dx over dt, hers decreases, minus y. Well, in other words, she gets turned off. So that's the dynamic here. And then we can take vectors in this space, x of t and y of t. Here's a point for the vector. Take another vector, x of t and y of t. In other words, we can plot this these points as we start to increment time. So visualize, you get a velocity vector in the state space, something that tugs at our point in some direction and with some magnitude that indicates how quickly it's changing in this love affair here, which we can rewrite in terms of a matrix setup, where we have that 0 and minus 1 and 1, 0 matrix, where the top row is Juliet's rule, because she's decreasing, and bottom row is Romeo's rule, because he's increasing with hers. And so now we have, again, this differential equation where the vector changes, that changes equal to a matrix M times the vector. So psi, in the psi equation, the vector in the brackets there packages up information like the various particles' position and momentum. It's still a vector. And again, it's that same rule. Again, the rate of change of the vector looks like a certain matrix times itself. Again, we have the h and it being scaled by 1 over h bar. So a certain matrix times itself, that is times the vector. But writing e to the m is a shorthand for plugging it into this long polynomial, the infinite Taylor series for e to the x. So when we write e to that power of that matrix, we're really plugging it into the Taylor series. So this expression is exponentiated in 90-degree rotation matrix by pi. It's 100% analogous to multiplying by imaginary exponents. Again, we could put it in we have e to the it, where I is the complex, we're part of the complex plane, the imaginary part of the complex plane. And we're rotating it again in the imaginary plane, which brings us back to this picture, e to the it, and the imaginary plane that we showed in number 6. So Grant ends, but here, this fundamental unit, I, that sits so interestingly in this fundamental equation for all the universe, is playing basically the same role as the matrix from our Romeo and Juliet example. What this I communicates is that the rate of change of a certain state is, in a certain sense, perpendicular to that state, and hence that the way things evolve over time will have to involve a certain oscillation. But again, at the very heart of current physics, what have we just seen? First, at its heart is a sleight of hand, a resolution of an infinity by a mere mathematical convention. This is the Zeno syndrome, the supposed resolution of the paradox by taking the limit of an infinite series, that is a mathematical convention. This is what Whitehead argued. We saw in number 53. We can take the limit of that series, 1/2, 1/4, 1/8, 1/16, and it seems to converge to 1. If we took that as a time frame, we converge in 1 second. But it's taking or using a mathematical convention to do that. And this, we said, is not a physical resolution of the paradox. We could substitute in a robot for Achilles. And then we could make him implement this halving algo. 1/2, then 1/4. That is, he's got half his steps as he goes. But to catch the turtle, he ultimately must stop, halt the algo. He must call a halt to it and take one truly physical step to step on the turtle, ignoring the algorithm. Now we've got a physical resolution to the paradox, but it ignored the mathematics, the algorithm he was operating. Similarly, this is not a physical resolution to how the field transforms. Second, there's no actual time in this. This is zero time. The t parameter increments, instant by instant, value by value. This is the infinitely divisible time of the classic metaphysic. It always comes back to zero, that is, unchanged. There has been no change. This is not the nature of the indivisible, ever-building, melodic transformation of the universal field. Remember, now, psi, the wave equation, is considered the complete description of the universal evolution. That is, that psi is literally true. For example, Sean Carroll and his adherence to the many worlds theory. Therefore, he says psi is literally true, nothing missing, nothing missing. Or Carl Friston and others. But this cannot be so. There is a large set of interrelated props, or stilts, or pillars, all with the same form of problem, holding up this architecture of physical explanation. To list just some: the Christochrone and Hodochrone curves, the resolution of Aristotle's wheel paradox, the calculus of variations, the principle of least action. The above, all of the above, save Aristotle's wheel, underline the Newtonian, Lagrangian, and Hamiltonian equations of motion. The zeroth law of thermodynamics, Buckingham's pi theorem, and more, and more, and more. If we look for 1 second at Aristotle's wheel paradox, the wheels rolling, the outer and inner wheel trace the same length, but clearly the outer and inner wheel have two different size perimeters. How is this possible? Then they trace the same length. Well, if we unroll the lengths, the perimeter lengths, out flat to a straight line each, then we're back to the fact that, or the idea, the concept that there's an infinite number of points on each line. Therefore, there's always going to be a correspondent point. That's the resolution. Let's remind ourselves from Bergson's point of view, each line, the 1D space, is created by an indivisible motion. The residue then, the space, we treat as infinitely divisible. So this underlying structure, with its infinities and zero time, It's everywhere, ubiquitous. But let's examine a few. First example, Fourier. A recent article in Aeon on the nature of the pixel by Elvie Ray Smith, co-founder of Pixar. Title up there, Pixels, the elementary particles of pictures based on a subtle unpacking of infinity. The pixel, it seems, was entirely derived from Fourier wave analysis. That is, constructing a complex wave or reconstructing a complex wave pattern, the bottom wave pattern there, into component waves, the 100, 200, 3 hertz frequency component waves. This via Kotelnikov's sampling theorem. By the way, this can also be done by spatial frequencies. So sampling. Here we have, notice the sampling points, this is in Kotelnikov, and reconstructing the whole from the samples. Now Smith notes, our everyday experience of the world, that is our perception, is a picture that changes in time. It's 3D, 2 dimensions of space and 1 of time. But Fourier, so to him, we don't even really see three dimensions. But Fourier and Kotelnikov theories still apply. So he's really implicitly applying this to human perception. A digital movie uses sampling to recreate that experience. We call the time sample a frame, and each frame is made of pixels. So again, just frame after frame after frame, using the pixels. But here are the equations. This Fourier is at the base of this. Notice, e to the I pi, sitting at the base. And let's remember, we've talked about this before, that in essence, what Fourier is doing, if you look at the left side of that picture, is we're taking these waveforms and placing them on a circle. And as the vectors corresponding to each wave rotate around, we start to trace out the waveforms. And 3 blue, 1 brown shows that with this method, we can actually recreate a nice picture of Fourier there. But at its base, the e to the I pi. Another example, ecological physics. Ecological physics is the dream of Bob Shaw. My thesis advisor, roughly 72 to 1976 at the University of Minnesota. He studied with Gibson at Cornell. He's the founder of the Journal of Ecological Psychology, the flagship of Gibsonian theory. The goal of ecological physics, continuous link between psychology and physics. And we'll be considering this paper, Modeling Systems with Intentional Dynamics, a lesson from quantum mechanics. 1994. I'm telling you, if you want to see the incredible intellectual power of my old advisor, just read this paper. It's awesome. This little statement here, notice the reference to Bergson, perception is virtual action, action is virtual perception from Shaw. That would take another whole discussion. So the question for the paper, and following Gibson, what is a rule for the perceptual control of action? That is for achieving a goal, or the intended action, the intent. For example, the mouse escaping or running from the swooping hawk, or I reach for a cup of coffee, it's my goal. Shaw models this as an organism environment system, and he's piggybacking on or extending the QM Schrodinger equation using the probability interpretation, I would note, which I note Erwin Schrodinger rejected, as we saw in 60. He veers ultimately to Feynman's path integral formulation of QM for better conceptualization, but Schrodinger and Feynman, he notes, are formally equivalent. So he's generalizing this by allowing new parameters for h, Planck's constant, in that equation that allow for extension to a larger framework of action and time. And for the equation psi, or QM's evolving particle, as the equation expresses it, we now are able to substitute an organism, for example, a mouse, with the time evolution over a larger scale of time for the action. So I'm stupendously oversimplifying the thought and method by which Shaw develops this, but this is the core. So one has to register, and let this register a bit. This is completely integrated psychology and physics, or better, subordinated psychology to physics, because think, if psi, Schrödinger's equation, is repudiated, so is this. I could make many observations. For example, this could and does not handle image-directed action. I intend to reach that coffee cup. It's an image of doing so. Now, the theory is supposed to supply to this, but for my number 9 and the critique of number 15 on ecological psychology, where the problem is because they won't put Bergson or Gibson in the Bergsonian framework, in the holographic framework, there's no theory of the image in the first place. So the theory of cognition starts to collapse. Another thing would be, how would it handle LSD and scales of time, perception, changes of scales of perception? In my opinion, the biochemistry is going to overwhelm the physics, which seems a strange statement, but when you look into the subject, you'll see. But for the point here, this is entirely zero time, with the infinity unresolved at its core. And it is the ultimate expression of the Kantian structure, where, quoting quote Bergson's statement of it, the idea of a science that is one, capable of binding the same force with the same force, all parts of what is given on all sides in equal solidity. In other words, where all phases of reality, physics, biology, psychology, are treated on the same footing, that is, the classic metaphysic. But in this framework, I know the brain, that is our cognition, created the classic metaphysical framework of space and time underlying this equation, underlying psi, that is the abstract 4D space of points, positions, with points corresponding to instants as an object moves. But the brain is intrinsically embedded in the organically, melodically, indivisibly transforming universal field where there are no such instants. That is, it does not dwell or operate in or function within the classic metaphysic. So this metaphysic cannot be brought to bear on consciousness and ultimately perception. Yet another example. We saw this in number 61, the database of physical laws. In 61, we saw Tom Campbell arguing that reality is a virtual reality. It's generated via a rule set, okay, by a computer, a cosmic computer, a rule set with a probability or probability distribution database at its core that it's using. And the rule set, we presume, of course, is the physical or mathematical laws. It's got to use those too. So in this database, we find the wave equation. Supposedly, its time evolution holds the superpositions with probabilities in which Tom is selecting the next event, instant by instant. He has to have this to explain the double slit interference pattern. Each time we send a bullet or a particle through the double slit, the probability distribution database tells where to go to make the interference pattern. but all based on Schrödinger's law. So this is the ultimate expression of the reality of mathematical laws. These laws sit there in the cosmos somewhere and direct the creation of the virtual reality. But this equation is based on mathematical fiction. The field does not return to zero over and over and over. It does not proceed 0 time to 0 time to 0 time. It cannot be the mechanism driving the physical transformation of the universal field. Again, there's no physical resolution. Again, Schrödinger himself denied its adequacy for reasons ultimately related and especially obvious at second-order effects. I have to pause and note here, a computer, that computer in the picture of Tom's there is a Turing machine. It must proceed state by state in 0 time. But Tom offers no other alternative to Turing computation. And another example where math is a reality. So this is taken from a discussion with Brian Greene with these 4 philosopher-physicists, David Albert, Sheldon Goldstein, I believe it's Sylvia Jonas, and Max Tegmark. And Max says, the electron's properties are just numbers, +1 or -1 or whatever, +1/2, -1/2. This leads him to stating that our entire reality is just mathematics. Max expresses his optimism that we will explain consciousness by mathematics, thus via computing or computers. He also expresses his faith in the simulation idea and tells Brian Greene, if you were being simulated, you would feel no differently. So Campbell aligns perfectly with Tegmark or vice versa. In essence, Campbell is kind of a reductio of Tegmark, with Tom's computer generating a virtual reality and explaining consciousness. So David Albert asked Tegmark, you're telling me the tree is the number? What does that mean? And Max defends this. Tegmark did not register Albert's point, the pure incomprehensibility of Tegmark's view, and that Max could not deliver anything more concrete to David Albert. So the tree is a bunch of numbers. So make the tree out of your numbers. How are you going to do that? This is like the simulation idea. That it's no different than simulating an AC motor on a computer. This does not run one Christmas light. The AC motor has real concrete dynamics, forces and dynamics that's creating those lights. But to make it real obvious, take our Turing machine there, formally equivalent. We have nothing but abstract symbol manipulation. How is this going to run a Christmas light or create a tree? Question marks. This is abject, unreflective enslavement to the concept of computation, that is, to the unexamined classic metaphysic underlying this notion. In all of this discussion, there was not one mention of time, not a mention. The discrete nature of time is so embedded, so ingrained, they never question it. There's no awareness of Bergson, who was utterly foreign to them. So let's look for a bit at the difference here. In number 49, entropy, time as a force, we went through Bergson's thought on this in great detail. The concepts are so non-existent, so just foreign to Brian Greene and his crew, that it's worth it again just to let's reiterate some certain points. Start with Bergson's question. For a conscious being to exist is to change is to mature is to go on creating oneself endlessly. Should the same be said of existence in general? For physics, a material object, a glass, a water, a cube of Lego blocks, change it via an external force. It becomes, to physics, just a displacement of parts. If the parts change, these too are composed of parts and displaced, and so on, until we stop at the supposedly unchangeable parts yet to be found. When a part leaves its position, nothing prevents its return, so a group of elements can always find its way back to the original state, by itself or by some external force. Any state can be repeated. Implication: the group does not go old. It has no history. We're back to this picture, an eternal return to zero, that is, unchanged. Concrete duration, as Bergson called time, to try to differentiate it from the classic metaphysics of time, is denied. Change must be reducible to an arrangement and rearrangement of parts. The irreversibility of time must be an appearance relative to our ignorance. The impossibility of turning back must only be the inability of man to put things in place again. We don't know how he could put the cup together back again, or the smashed egg. So growing old can be nothing more than the gradual gain or loss of certain substances. For example, loss in cells of internutritive substances, or increase of toxins. As an isolated system, the position of its points is determined by the position of the same point at the previous instant, thus by equations with coefficients, or ds dt, dv dt, etc. Is this so with the laws of life, with biology? Only so if given an a priori agreement to liken the living body to an inorganic body. Treat the living systems as studied by the astronomer. In other words, we're back to the Kantianist conception, the idea of a science that is one, all sides being equal. The instant immediately before is connected with the present instant by the interval dt. So we're saying the present state is defined by equations with differential coefficients, ds dt, dv dt. That is, by present velocities and present accelerations. That is, a present considered along with its tendency. But for the organic, this mathematical treatment is not possible. To quote Bergson, the idea that a living body might be treated by some superhuman calculator in the same mathematical way as our solar system has gradually arisen from a metaphysic which has taken on a more precise form since the physical discoveries of Galileo. Its apparent clearness, our impatient desire to find it true, that is, witness AI. We're going to, by God, stick human intelligence into the AI framework. The enthusiasm with which so many excellent minds accept it without proof should put us on our guard against it. For a living body, the present instant is not explained by the immediate previous instant. All the past of the organism must be added to that moment. This is the cardinal difference between abstract time and concrete time, that is, between zero time and real concrete time. It is the teeth moment in this framework that counts, that is the present. It's a mere instant, not the interval. The parrot rolling around, the full interval. The scientist himself places it himself at the extremity of the interval, the end of the interval right there, say each time his tail goes by. He divides the interval into infinitely small parts, the changes in time, dt's, now computing accelerations, velocities, that is, tendencies. But still he's speaking of static moments, not flowing time. That is, he has a series of such extremities or ends of intervals, or instants. To quote, the world of the mathematician, a world that dies and is reborn at every instant. The world of which Descartes was thinking when he spoke of continued creation. And we've noted this before. Just moving the cup across that continuum of points and positions corresponds at each instant to a cube of the all of space, all unrolling via deterministic law, block to block to block. Ultimately a 4D block. But each block is frozen. There's no change possible in that instant. It's a mathematical instant with no duration. And so we would need a God to move from block 1 to block 2 and then create block 2 from after block 3. So we get continuous creation. In physics, Bergson knows fools itself. It cannot escape continuous creation. This instantaneity is an abstract limit. This isolation is an abstract limit. Neither is reached in the concretely transforming concrete world. You do not remove the organism, the glass of water, the caterpillar from the transforming universe. No system is isolated from the indivisible global transformation. But this isolation assumption rests at the base of measurement, and thus of the laws of science and its mathematical laws. Bergson, we saw, use boiling water on a stove. Yes, the system can be practically isolated from the transformation of the universal field, but in reality, it is bound up with other objects and operations. He says, in the end, I should find that our entire solar system is concerned with what is being done at this particular point of space. But to imagine this is to superimpose yesterday on today. I'm vaguely imagining placing stove yesterday on stove of today, kettle on kettle, water on water, duration on duration, as though nothing has changed from the 2 days. Again, nothing changed, but yesterday had to wait for today's. That is, time had to halt, and everything become simultaneous. This happens only in geometry, and only in geometry, a purely spatial operation. In this inductive process, for both physicist and geometrician, time does not count. What this induction discovers, the law of the mathematical order has no positive reality. It is the form towards which an interruption proceeds. A sort of Zen-like statement, but we've seen this is the core within Bergson's vision. It is consciousness, the inextensive, that pushes, so to speak, the universe into existence constantly. This push is an intensive force. The relaxation, the lessening of this force is the emergence of the extensive, the material world, with its geometric tendencies, its mathematical order. Approximately, yes, there is an order, approximately mathematical, immanent in matter, and science progresses towards and approaches this. To quote Bergson, for if matter is a relaxation of the inextensive into the extensive, and thereby of liberty and into necessity, that is apparently deterministic laws, it does not indeed wholly coincide with pure homogeneous space, that is, those nice homogeneous instantaneous blocks. It does not coincide with those. Yet, it is constituted by the movement that leads to space, and is therefore on the way to geometry. So it never coincides. The extended world does not equal extensity. The material, actual concrete material world. That is, this, the abstract space, the 4D continuum of points, positions, underlying the classic metaphysic is an ideal limit, never concretely reached. This, in my opinion, is what the infinities are telling us. Again, there's 2 kinds of order that is simply not being recognized. The natural direction, tension, continuous creation, free action. The inversion of this, extension, externally related elements, geometrical mechanism. The second order is geometrical, the necessary relation of cause and effects. It's the admirable order of the astronomical, and it can be foreseen mathematically pretty well. The first order, the vital or willed, a symphony of Beethoven is our nice example. It's no less admirable in order. It's originality, unforeseeability itself. So I put Ode to Joy up there as an example of the intensive in consciousness coming forth, expressing in the exterior world. But it is the first, the vital, that is devolving, diminishing into the second, the mathematical, as an ideal limit. And so, obviously, we have the symmetric case. In reality, as we proceed from physics to biology and psychology, things are becoming increasingly less describable by mathematical law. Physics almost gets there. It almost reaches that ideal limit. But it doesn't. And this gets worse and worse as we go back up toward the inextensive, to consciousness. Time. It's not just about continuity, as we saw Grant refer to in the beginning, especially not the continuity of an infinitely divisible or dense set of points on an infinitely divisible line. It is an organic continuity, a melodic continuity, where the state of each note, using notes for instance, reflects the entire preceding series. It's a building, a development. Without this property of time, there can be no quality. Yes, no qualia, no mellow wine, nor mellow violins, nor mellow beings. As we noted, mellowness can only exist by being able to build in a melodic, building, indivisible time. It does not exist in a static instant or state. The mathematician's continuity condemns us to the homogeneous, static, mathematical point-in-time extent blocks of space, qualityless. Yes, the blocks of zero time, and hence the hard problem. Postscript. A bit into the discussion, Lex asks, so why do you think the fundamentals of quarks and the nature of reality is so compressible into clean, beautiful equations that are the most part simple, relatively speaking? Grant. I have no idea. Why is it simple? It could be that there's just a filter in place, that the only thing that physicists find interesting are the ones that are simple enough that they can describe it mathematically. But as soon as it's a sufficiently complex system, well, that's outside the realm of physics. That's biology, or whatever have you. The question that Lex asks, why is everything so compressible? Assumes the current mindset. Everything is not so compressible. It assumes the validity of the Kantian structure, which is the current mindset. It's not compressible. That is, all reality can be assumed as the classic metaphysics and its mathematics. The picture we display of consciousness, the inextended, is the precise, well, the antidote to this idea. But the answer from Grant displays the current refusal to come to grips with the core of the problem, which is the nature of time. What drives the arrow around and around? What moves the instantaneous block, one instantaneous block to the next? Says Bergson, it's the very essence of mechanism to consider as metaphorical every expression which attributes to time an effective action. And that's precisely what we have going on in the zero time framework. In other words, the nature of time as a force has to be brought back into our considerations. So next we'll see. Till then, signing off.